Kia ora tātou, ko Anne Williams tōku ingoa. I'm one of Engineering New Zealand's newest board members. I lead Becca's Geotech business, and so I have a little bit of understanding about some of the components of concrete and some of the challenges with it. But I am, like you, looking forward to learning about the concrete industry's carbon emission reductions to date and the initiatives guiding the concrete industry to net carbon zero by 2050. So it's my pleasure to welcome you to this third session of Engineering New Zealand's Climate Resilience Series, and to now introduce you to our speaker, Ralf Kessel. Ralf is an architect. He's registered with the New Zealand Institute of Architects and AK Berlin and ARB UK. He's worked for over 16 years as a project architect for a number of German and Irish-based practices, during which time he was involved in apartment developments and commercial and public properties with a focus on energy efficiency. Ralf lists amongst his achievements a range of aesthetic and practical concrete applications, including precast panels, in-situ floor slabs and concrete masonry. Ralf joined the Cement and Concrete Association of New Zealand, so that's CCANZ, now part of Concrete New Zealand, as a project manager in March 2009. And while at CCANZ, he authored the CCANZ Code of Practice for Weathertight Concrete and Concrete Masonry Construction, and is also the author of CCANZ Apartment Design Guide and Basement Design Guide. Ralph's also the convener of the Concrete New Zealand Masonry Sector Group and the Concrete New Zealand Sustainability Committee, which was established in May 2019. Over to you, Ralf.
Yeah, thanks very much for the lovely introduction, Anne. And hello and thanks for inviting Concrete New Zealand and myself to talk to you at your climate conversation series. So welcome everyone on the other side of the screen as well. Our CEO, Rob Gamester, intended to be here today, but was held up with different matters. Hence, I'm happy to jump in. Maybe some words to myself I want to add on. Yeah, as Anne mentioned, I'm Ralf Kessel, the Concrete New Zealand architect, originally from Germany, as you can hear in my beautiful or not so beautiful accent. Having worked on a wide range of projects, commercial, industrial, residential in Germany and Ireland for 16 years before I came to New Zealand. And that was 13 years ago when I joined the back then Cement and Concrete Association. And in the meantime, I'm very happy to have become a New Zealand citizen in 2016, to be a real member and really rooted now into this beautiful country. So today I will provide an introduction of the New Zealand concrete industry and Concrete New Zealand before I will outline concrete's journey towards net zero carbon. And I will just pick my pen here because I may need that for the next session. So today I will cover a quick introduction, and after that introduction I will outline our progress so far against a 2005 baseline. Then I talk about our roadmap to 2015, so which brings us to net zero carbon. We are currently collecting data from our industry, not just carbon related, and will also develop a sustainability report from there. And then I will also give you a brief look into concrete and how we can positively contribute to the 17 UN Sustainability Development Goals, before then finally concluding. So upfront, a quick introduction of our industry. So since I joined the Cement and Concrete Association 13 years ago, it has been replaced by Concrete New Zealand in 2017. Back then, the sector associations such as Precast Concrete, Ready Mixed Concrete Association and Concrete Masonry consolidated under one umbrella to speak with a unified voice. And the other positive is we can continue our service of advice, education and help even stronger. And actually, one of the drivers for this consolidation was the opportunity to coordinate our industry's efforts around sustainability. So our industry, in a nutshell, we produce about 4.5 million cubic meter of concrete per annum. This is all quality assured material, all quality assured by a plant audit scheme. And the other thing, the concrete, our material is readily available. So no material shortage here, we can and do deliver. Then the concrete industry here in New Zealand creates about 25,000 jobs and generates a revenue of near $3 billion. However, sounds all good. This activity also comes with carbon emissions. And our industry, as every other industry, will have to reduce emissions to address climate change and to comply with New Zealand regulations. So our industry accounts for about 1% of New Zealand's emissions. And concrete's interest in sustainability has started a while ago. Back in 2006, for example, we launched the Concrete 3 program and awards to raise awareness of concrete's contribution to New Zealand's sustainable developments across all areas of social, economic, and environmental matters. Since then, the Concrete 3 Award is being given to exemplary projects at the annual Concrete Industry Conference. And the next conference is scheduled for 13 to 15 October this year, will be held in Rotorua. So our carbon reduction progress so far to today. So regarding emissions, our 2030 goal, which is a 30% carbon reduction measured against a 2005 baseline. And to speak with Bon Jovi, we are halfway there. Our 2018 data shows that emissions have been reduced by 15%, and this came against an increase in concrete production of 13% and a population increase of about 18%. So again, this is since 2005. A new set of data looking at 2020 emission levels is currently underway and exercised by independent consultancy ThinkStep. So we should be able to publish a new set of data later this year. So how did we achieve that 15% reduction? So the reductions were achieved by partly replacing fossil fuel, which is typical coal, fossil fuel for heating the kiln, the cement kiln. So, and we replaced that coal by waste timber and also car tires. So again, for heating the cement kilns. Then by partly using SCMs. So what are SCMs? That's the abbreviation for so-called supplementary cementitious materials, which are low carbon substitutions, recycled or natural, partly replacing cement. And by the way, not sure if you're aware, but of all the emissions associated with concrete, about 85% stem from cement production. And here 40% from the fossil fuel to heat the kiln, and 60% as a chemical reaction when we separate lime from limestone during calcination. So that's why it is a good idea to look at cement replacement, cement or clinker replacement, or clinker reduction, to say it this way. Last but not least, we have also turned to more energy efficient plant equipment and more efficient engines and transport vehicles in general. So that was the 15% reduction. And this has been validated by ThinkStep. And I would just like to play a few words from their technical director, Jeff Vickers. Let's see if that works.
From an innovation perspective, I already see really encouraging progress from the likes of Golden Bay Cement, who have already substituted 30% of their coal for biomass, which is a great achievement, and they're going to go even further with substituting tyres, which contain some natural rubber, to do even more on that fuel substitution sort of standpoint. And you can see those good results reflected in their environmental product declaration, for example, which shows that their carbon footprint per tonne of cement is certainly, world leading. It's definitely below average on a global scale, and that's a really great example of positive progress. I'd also like to commend organisations like Allied Concrete and Wholesome for producing environmental product declarations. Allied Concrete came out first with an EPD in the New Zealand market and really showing leadership in that space.
So this is good success. However, we can't be resting on our laurels, and there is still a way to go, and pressure to deliver is building up ever more since global warming is not giving us much more time. So upfront, interesting for engineers, designers and specifiers, it is important to understand the quantities of carbon the chosen concrete comes with. So before I talk about our further reduction levers and reduction initiatives, I just want to talk about the emissions as of today. And once again, you need to know for your carbon briefs and for your assessments of the materials in regard to sustainability, how much carbon comes the concrete with. And this information is provided by EPDs, so an environmental product declaration, which is a verified way to measure the carbon footprint of a material. And as you may recall from the earlier shown video, Jeff Vickers mentioned that Allied Concrete was the first company in New Zealand to have ever undertaken an EPD. And I show you here an extract by example of a 17.5 MPa concrete. So this EPD goes up to 50 MPa concretes, which are our standard concretes, our ordinary concretes. And if you look at, let's say, Alexandra, so the concrete from the Alexandra plant comes with about 245 kilogram of carbon dioxide per cubic meter, which is equivalent to about 100 kilogram of carbon per ton, given concrete's density of 2.4 ton per cubic meter. Christchurch plant is a bit more modern. So here we have a reduction of another 38 kilogram, brings us down to 207 kilogram. And the same applies for other concrete producers. Here, the Firth EPD, the Wellington plant, the Wellington plants come with around 200 kg of carbon dioxide per cubic meter. And so does the Whangarei plant as well. Here we have even a bit less. EPDs for Golden Bay Cement, Holcim Australasia, Richmond Concrete and Stevenson's Concrete here in New Zealand are further EPDs available with other companies following soon. So coming back, the next question is then how we will reduce these already low emissions further. So we'll show you our roadmap, which brings us to net zero carbon with the following slides. In 2020, member companies of the Global Cement and Concrete Association, and Concrete New Zealand is one of the members. So we came together as leaders in the sector to commit to producing carbon neutral concrete by 2050, in line with global climate targets, which means accelerating the carbon reductions that we have already achieved. So this 2050 roadmap sets out in detail how collectively, in collaboration with the built environment stakeholders and policymakers, we will fully decarbonize the cement and concrete industry, and then finally, as a result, provide net zero concrete for the world if you want so. So this roadmap has been recognized by the United Nations and also by Greenpeace, who said that if the concrete industry delivers according to this roadmap, that will be significant. So the roadmap for net zero concrete is a commitment of global members, companies to assist in building a sustainable world of tomorrow. And here in New Zealand, we are currently collaborating with our members to adopt this roadmap and tailoring it to a New Zealand context, which will be very similar to the global roadmap, past, present, and future actions. So the roadmap will set milestones with the actions shown underpinning the strategy. Until 2020, we have already achieved a 15% reduction and will continue the measures which brought us here to achieve another 15% until 2030. We are also in the progress to increasing the uptake of SEMs, of cement supplements, to accelerate the process, and also to improving energy efficiency for our plants and trucks from 2030 onwards. So carbon uptake and utilization will definitely play a more significant role from 2030 onwards. But until then, we are very confident that we continue the progress and get another 15% by SEMs and more energy efficient plant and vehicles. So here are the initiatives illustrated in block graphic, improving efficiency in clinker production. So that's the first one here. Yeah. So for your benefit, what is clinker? So clinker consists of 3 to 10 millimeter lumps, mainly made from heated limestone. So this is what comes out of the kiln. And the clinker is then milled to make the final cement product. And at milling stage, it can be blended with SEMs. So we just look to reduce the energy needed for the cement clinker, but we also look at saving cement in general, and that would be done with replacements such as slag and fly ash. So there would be recycled SEMs, recycled supplements. Slag, as you know, is coming from steel production, and fly ash coming from electrical plants when they use and burn coal. So we can use that material and chuck it into cement and reduce the cement amount significantly. Microsilica is another option, but here with microsilica we replace possibly only 10%, up to 10% of the cement. Microsilica is mainly used to increase the strength of the concrete. Slag or fly ash, 30% is easily possible, and slag 50, 70. In Europe they have even achieved 90% replacement by slag. And then there are natural supplements as well, such as volcanic ash, material what the Romans have used for their concretes when they, for example, built the Pantheon 2000 years ago, but also other materials such as diatomites, which are compressed algae, can be used to replace cement to today's standard by about 30 to 40%. So to ensure that our engineers still get the specified concrete. Higher replacement factors may be possible in the future, but at the moment we look at 30 to 40%. So the other thing is then improving efficiency in concrete production, so optimizing the mix design and looking at the constituents and ensuring that just less green aggregate is used. Then we also decarbonize our energy in regards to electricity, so using more and more renewables. But we will also have to talk to engineers, specifiers, and designers to get the client brief upfront right, so we can optimize the design. There is already some carbon uptake in place here in New Zealand. I wonder if you've heard about carbon capture. Carbon Cure is a company from Canada. They are facilitating carbon capture. They're taking up carbon from other industries such as Marston Point refinery, and that carbon is then brought into a liquid aggregate state, brought to a concrete plant, and here injected into the concrete. Stevenson's Concrete have done a couple of things with this, and other companies are following. So Carbon Cure, it's a pretty straightforward chemical process which happens in the concrete. So if you inject carbon dioxide into the concrete, it will find calcium and also oxygen, and then it combines to calcium carbonate, so CaCO3, which is in fact rock. So it improves the strength of the concrete slightly, and the other benefit is we reduce the amount of cement needed. At the moment, the cement reduction level is at about 7%. You may say it's not much, but it's contributing. And in summary, we will get, in summary of all our initiatives, we will get to carbon zero in 2050. So the other thing I wanted to mention is carbon sink. So this is something or we'll possibly talk about this in a minute, recarbonation or mineral carbonation. I leave it for maybe 2 more slides, because just the next slide I wanted to talk about the levers here in some keywords. So what are we doing until 2050? Increasing the use of SEMs, recycled or natural. We will efficient energy sources and equipment for clinker production, but also for concrete manufacturing per se, including the delivery process, which includes transport. And here, Golden Bay Cement, for example, have ordered the first 2 hydrogen engine trucks. The next one is driving waste, minimization and manufacturing delivery in construction, and then using recycling processes to minimize the use of virgin materials, in particular aggregate. So we recycle, we increase the use of recycled aggregate, but also adapting new technologies where appropriate or where technology has been proven, such as carbon capture and utilization. being engaged with our specifiers and engineers and designers in general. But again, also making use of carbon uptake, so-called recarbonation or mineral carbonation, since exposed concrete is actually the largest man-made global carbon sink. So here my slide on mineral carbonation. So on our path to decarbonation, mineral carbonation is actually helping us. Mineral carbonation is described as a process of carbon dioxide present in the atmosphere being absorbed by externally exposed minerals such as concrete. This works very similar to the chemistry which I just explained before with carbon cure. There's lime present in the hardened concrete, so in the exposed concrete, there's oxygen. So the lime, with its, once again, chemical abbreviation CaO, attracts CO2 to compose CaCO3 calcium carbonate. So it makes the exposed concrete even stronger and creates another bit of layer of rock if you want so. So the UN's Intergovernmental Panel for Climate Change, as you know, sets out the latest scientific understanding of climate change, and in their latest report, which was released in August 2021, they have recognized for the first time that concrete mineral carbonation sequesters about 25% of concrete's initial emission. So it's now expected that international accounting will be updated to consider this, and EPDs, as earlier seen, will also reflect the latest science in their figures. But importantly, how much carbon is sequestered by the use or by recarbonation can be calculated by the use of an add-on to the EN 15804, the standard for EPDs. So by use of this publication, I think here is the title cover of that, this publication has been published by the British Research Establishment. So by use of this publication, you can actually calculate the amount, the quantity of carbon sequestered by your exposed concrete. What else is up? So we have commenced collecting data from our members in all areas of sustainability, not just carbon. And we expect to have a report ready by early next year to provide a comprehensive understanding of our sustainability achievements. So data will be collected from energy and emissions and carbon, from electricity, biofuel, diesel, petrol, hydrogen, coal, and renewables use. Then in the waste sector, we look at deposed material to landfill or recycled, returned concrete. There are a couple of companies here in New Zealand which take the oversupply. As you are aware as engineers, there will be always a bit more supply to the site to ensure there is enough. It's better than the other way around. There is not enough. So that oversupply is returned to the concrete plant, and there are some companies who fill the return into forms for shaping blocks and retaining wall blocks, etc. So there in this field we have done quite a bit already. Recycled aggregate used in concrete or secondary aggregate as byproducts from other industry, glass for example. In the water segment, we look at collecting rainwater, recycling water, water reduction by plasticizer. So if you add a plasticizer in the concrete, it will automatically reduce the quantity of water we would need. And we also measure the total water use and water intensity. The built environment, that will be more reported on by case studies. So they will paint the picture. In the segment of our workforce and health and safety, which is definitely one of the most, maybe even the most important part of our industry. Health and safety is, I think, for every industry super important. So we are recording the total recordable injury frequency rate and also the lost time injury frequency rates. In the socioeconomic area, we can measure the economic impact, what value add the industry made, and looking at job diversity, training, and also at our figures, total ready-mix concrete production. And there are also some community schemes in place. So we will have a detailed report on this possibly by early next year. So where do we see concrete fits in with the 17 UN Sustainability Development Goals? So goal 3, good health and well-being. So we're providing for our communities to thrive, helping to designing safe infrastructure and places. Goal number 6, clean water and sanitation. So we have water treatment plants made of concrete, and they are essential to delivering the 3 waters infrastructure revolution, if you want so, which is happening just now at the moment. And goal number 7, affordability of clean energy. So for hydrogen and wind power. So for wind power, we need concrete for the big foundations, etc. Number 8, decent work, economic growth. So the concrete industry is regarded as a good employer. We have job activities contributing to the economic well-being. Concrete-made infrastructure is a must for our economic growth and possibly also for our well-being. Number 9, industry innovation and infrastructure. We are innovating in the area of supplementary cementitious materials, plant-based binders. We're looking at plant-based binders like algae and maybe even carrots. There have been some research undertaken in Germany with carrots, very interesting. They actually found that carrot is a storage of moisture, and that moisture, when it's part of concrete, is able to trigger dormant cement particles. Not sure if you know, but not every cement particle will be triggered to bind. Some remain dormant, but research in Germany has found that carrots actually increase the particles actually being triggered. Number 11, sustainable cities and communities. So we are building durable structures, protecting communities from, for example, floods, etc. I think this is very important for the National Adaptation Plan or National Adaptation Plan, which has been introduced by Minister Schor recently. So it's not just the reduction plan, but also the adaptation plan to deal with climate change. So we can provide definitely structures to help us here. Then number 12, waste and circular economy, recycling water, recycling concrete returns, reusing byproducts from other industries, so recycled materials, and generally number 13, climate action. So we are reducing emissions by SEMs, by carbon sequestrations, and also by energy efficient plant and transport devices. And number 70, partnership. So we definitely have formed some partnerships also even with schools and supporting other social projects. And there is more to do and more to come, but I think we are on a good way at the moment. So because I think I don't have so much time, I think my time was about 30 minutes as I understood. So coming to an end, and in conclusion, I want to say that New Zealand's concrete industry supports the zero carbon legislation. We have already made good progress by reducing 15% of our 25 carbon levels, and will have reduced our emissions by another 15% by 2030. We will be guided by our roadmap of initiatives and milestones to achieve net carbon zero by 2050, and see here 5 key areas to get us there. The first one is lower carbon clinker energy as well used to produce the clinker, but also reducing the cement per se by replacing it with SEMs. Then low emission transport, such as electric vehicles and hydrogen vehicles, energy efficient plant equipment, also here looking at going more electric and using more renewables. And we are lucky in New Zealand that already 85% of our electrical energy is produced by renewables, water and wind and geothermal. Then waste minimization and recycling. And as I mentioned, we have some places, some initiatives in place already with concrete returns and taking up other industries' waste, but also carbon storage and uptake. And here we have started with carbon cure, and I'm sure that technology will be coming to, let's say, it will really be accelerated, looking at other initiatives and other areas where carbon is already used as a commodity, for example, for this pest trap in New Zealand, I think Good Nature it's called. So these guns are triggered by carbon. Carbon dioxide is also used to clean those delicate mirrors from the telescopes, etc. So it possibly becomes also more commodity in the future, which will help us again to get rid of carbon. So yeah, what my last slide is maybe a question for you. What we want from the engineering fraternity, so start specifying green concrete. If you want to know how that works, you have to come to us and talk to our stakeholders. There are some means in place. Allied Concrete, for example, they are bringing in hundreds of tons of slag and building a facility, a storage facility currently in Auckland. We have Firth and we have our other stakeholders, and Gold Bay Cement, for example, who are using a lot of waste timber and car tires to replace coal for the kilns. So we can definitely help you. Our industry can definitely help you to get your desired concrete with lower carbon. So also look out for our roadmap, which will be published by end of the year. And yeah, it's just important to keep up the conversation with us. So yeah, with this slide, I would end my presentation and would like to say thank you for being here. And I believe there's now a Q&A session. Is that right, Anne?
That's correct. Fantastic. Well, really interesting presentation. Thank you, Ralph. And I see there are a few questions already in the Q&A, but I just give people a moment more to add to those and ask a question of my own. And did I understand correctly at the outset of your presentation, you identified that perhaps 13% of the reduction in carbon achieved to date was due to a reduction in concrete production itself. Is that sustainable?
No, that's I was not clear here, and sorry for the misunderstanding. It's the other way around. So we have produced 13% more concrete than in the year 2005. In 2018, 30% more concrete, but still we have reduced the overall emissions by 15%. Okay. So there would have been about 18 or 90% per concrete cubic meter or ton or unit actually. But the total was 50%, yeah.
I see. Brilliant. Thank you for that. All right, there's a question here. I understand that concrete reabsorbs CO2 as it ages. Is a life cycle approach, a CO2 reabsorption, weathering carbonation, part of the current discussion?
It's part of the current discussion, but it's not considered. And as far as I understand, the New Zealand Green Building Council, they have not considered this at the moment, because they also have not considered biogenic carbon for timber. Because my understanding at least is that they're focusing on upfront carbon. So A1 to A3 and maybe A4 to A5. So A1 to A3 is product manufacture, and then A4 and A5 is the construction process, so on site. And the sequestration of concrete via mineral carbonation would have to be considered under a life cycle assessment stage B, under class B, under operation. And my understanding is that biogenic carbon would fall under C or under D. And at the moment, the current discussion is focusing on upfront carbon, because we just want to reduce carbon now at this stage, at this moment. And that's why it's not so much considered, but it will be taken up, I'm sure, and it can be also taken up already by the New Zealand Green Building Council, but I believe, if I'm right, it has a bit of lower rating, but I might be wrong here. But yeah, basically.
Yeah, cool. Can you give us advice on helping our clients to enable optimization in their design? What tips would you recommend for engineers in these conversations?
Yeah, so the first most important bit is talking to us. And I said already that our concrete members focus on different initiatives, on different means. So Allied, for example, is using a lot of recycled material, recycled cement supplements. Other companies, Firth, they are looking into reusing the cement up front, because they get the cement from Golden Bay, and Golden Bay is already a world leader in carbon emission reduction. Stevenson's Concrete have looked into and are using carbon cure. So there are various, and the same applies for Richmond, Higgins, and all the other concrete members. They all do fantastic stuff. But it's important to understand what exactly you want, what type of concrete you need. And that's why it's really important to talk to the concrete providers themselves for your specific project.
Good advice. Okay, our next question is possibly a little tricky. How do we intend to measure a way to consistently measure the percentage of recycled material in concrete for infrastructure?
Yeah, that is a part where the engineers are asked and needs to be monitored. So the engineers of our infrastructure projects, or the project manager with transport agency, somebody needs to be at the level where they measure what quantity exactly of any recycled material goes into the material. For the example of concrete, if you say we use maybe 10% sand replacement by glass, then it has to be captured at one stage. The concrete company would know, but it has to be collected somewhere. It needs to be for the whole project. So I understand that would be normally done by the project manager. If there is not a project manager, specify the engineer or architect would do this. Or if there is a large entity who is the client, then it can be also done at client stage. But there must be one place where it's collected.
Okay. So Kathy, if that properly answers your question, great. And if not, do post another one.
Yeah.
Cool. Can you expand more on the viability of hydrogen to save the emissions associated with clinker production?
Well, there are tests and trials overseas, but I'm not up to speed with the current stage there. I think it's just important that we consider that we shall use green hydrogen and not blue hydrogen. So green hydrogen is really environmental friendly, while blue hydrogen is coming from other sources. So with blue hydrogen, I understand we have to heat water and have to use energy maybe which is not environmental friendly. That would be then blue hydrogen, to my understanding, and green hydrogen is when we have all the energy used for that coming from renewables as well. So it's possibly a bit early to talk about hydrogen in concrete production, but it's for sure that we start using hydrogen vehicles already now. As I mentioned, that Golden Bay Cement have ordered the first 2 hydrogen engine trucks. So we are definitely with transport there sooner than we possibly thought.
Brilliant. Yep. So regarding carbon capture for making raw products, is there any options for capturing carbon from geothermal energy production, such as in the Central North Island, and using this in concrete plants?
Well, yeah, I think we can definitely capture carbon from every energies, every industries, as long as we have the correct devices here. I think the device we're using here for the Marston Point refinery, that's a Linde product from Germany, and they could capture, if they are established and set up appropriately, they could definitely capture carbon from all industries. So that is really the question where the investment can be done, and who is the taker then of the material, but I'm sure it can be done. So for concrete, yes, we can use carbon dioxide within our concrete, and the technology is already here. It's used heavily over there in the US, in Canada, and also in parts of Asia. And I think in Scandinavia they started to use this as well now. And due to our geographic location here in New Zealand, everything comes a bit later to us, but we definitely will benefit of the invention from overseas as well in the long term.
So do you have a feel for what % of cement is currently imported, and to what extent are we offshoring emissions?
Well, it's about, don't nail me on that, about 60% is locally produced, about 40% is imported. And but that varies. That varies from time to time. We only have 3 cement providers here in New Zealand. 2 large ones. The one is Golden Bay Cement, so up north. They are the local ones. And then we have Holcim, a huge international company, Lafarge, and both deliver absolutely top quality cement. And as well HR Cement as a smaller company, and as well they're delivering outstanding quality cement. They get their clinker from overseas, but they're refining the cement here. So they're milling the cement here, and they would be able to blend in some supplements as well at that stage. So all 3 companies deliver absolutely top world-class cement here. So no such things like you hear sometimes overseas. Because our materials are checked, and there's a quality insurance scheme like plant audit schemes, etc. in place. So and they make sure that all our material is complying with our standards, which the engineers rely on.
Right. Can you explain the future of waste concrete? So probably a related question, and utilizing recycled aggregate.
Yeah. So waste concrete would be another term for any concrete which has some form of waste as a constituent. Recycled aggregate can be a part of that. Recycled aggregate could be crushed and made brought into smaller pieces, but recycled aggregate could also be where we separate the actual aggregate from the cement particles. We use partly car tires even in our concretes. Wilco Precast is a good example from Auckland. They have created those supersized retaining wall blocks. I think they are 2 by 2 by 2 meter almost. And they have a big chunk of car tires in the middle of the block. So they're just hiding, taken up the car tires and surrounding it with concrete. So that's one thing. Then glass is used by some of our members, and they're replacing sand, not the coarse aggregate, but the fine aggregate by sand. So that is done as well, and we take up byproducts from other industries such as slag, granulated slag, and also fly ash. So there are various initiatives in place where we take up waste from other people, from other industries, and make use of it to create a great product which will last 100 or 200 years.
So use of car tires, you've mentioned that a few times, it makes me wonder, are there any sort of negative side effects from use of car tires? While it might reduce carbon, it might have some other detrimental effects to the environment, or do you have a feel for that?
Well, not when they are already produced. So if you would them to put them to landfill, they could release some not so great elements into the ground.
True.
So if they are captured in the concrete, that's safe there. And if they're used as biofuel, you can so there are parts of the car tires which is a biofuel, not everything, but certain parts of the rubber is a true renewable biofuel. And once all the other gases will be filtered out, and so that there wouldn't be any gases going into the environment, that makes it definitely safe for us using car tires.
Nice. So I have a question here. I wish to know more about your workplace health and safety, the measures or system you have in place to ensure the risk arising from these new changes aren't affecting workers and non-workers. So a slightly different type of question. Do you have any framework to ensure these measures, which will be in line with the roadmap to net zero carbon?
Yeah, we have our health and safety framework for our members. We have also courses for our members and for the new members to make sure that everyone also complies with the 2014 Health and Safety Act. So, and then we measure, of course, our injury rates, which are quite low. And if we see a risk then it's definitely addressed relatively soon.
Yeah. Where is the best place to go for information on green concrete? Does Concrete New Zealand have publications on this?
Yeah, once again, because it's all pretty new, the topic, it's the best to talk to us, and every company is implementing different initiatives. And since we speak for our members, yes, but they are still in competition with each other, and they would not give necessarily every secret away. So that's why I always can recommend to talk to the concrete suppliers directly. Go to Firth, go to Ella, to Higgins, to Bridgman, to Stephen, then you name them. So that's the best to do, because at the moment, because it's still relatively new and also business-wise sensitive information, yeah, we just have to tell you, please talk to our members directly. And of course, we have then our roadmap available by the end of the year, where you can see in which areas we are able to deliver. And then we will also have our sustainability report from early next year on available. So for you to understand which other areas are we contributing, and what are we doing in regards to waste and socioeconomic and all these other topics.
Great advice. Thanks, Ralf. A question, would you be able to provide any insight into the concept of sustainability by technology, i.e. new procurement processes directed by circular economy models and full life cycle management through 3D modeling and digital twins?
Yeah, thanks. That's definitely a very, very interesting question, but possibly more suited to somebody who is familiar with all the BIM software products, etc. I mean, there are some standards in place how to create a carbon brief, how to design a carbon brief, which is in effect really looking at the material you are producing, and then the quantity of the material, and then go into EPDs and see how much carbon comes with this material. But I'm possibly the wrong person to ask that question. I would go to somebody maybe at Baker, who is very familiar with these software programs and can give a more definite answer.
Many thanks. So that brings us to the end of the questions that are posted. I'll just give everyone a few seconds more to post any final questions. Otherwise, I guess it's my pleasure to thank you very much, Ralf. Hugely knowledgeable, obviously, in this area, and really great to have your insights, and great to see what the concrete industry is able to have achieved so far, and the roadmap forward to 2050. So, very many thanks, Ralf.
Thanks very much. My pleasure. And yeah, you enjoy the rest of the day. Thank you.
Brilliant. Thank you.
Bye.